Hello everyone. Welcome back to BNP 20803 Structural Analysis and Design class for Section 2. Today we will do example calculation on singly reinforced rectangular beam. Let's do it. Example 1.1. The cross-section of rectangular beam is shown in figure below. Using stress block diagram and the data given, determine the area and the number of reinforcement required. Information given. Design moment 200 kN/m. Characteristic of concrete, FCK 25 Newton per millimeter square. Characteristic of steel, FYK 500 Newton per millimeter square. Then, cross-section of rectangular beam as per shown in figure 1.1r. Breadth, 250 mm and depth, 450 mm. Let's do it. Solution of example 1.1. Step 1. Calculate the ultimate moment resistance of section, M ball. With using equation 7. Refer slide note chapter 3, pages 8. M ball equal to 0.167 FCKBD square. And substitute information in the equation is 0.167 times 25 times 250 and times 450 square. The answer is 211.36 times 10 power of 6 Newton millimeter, and in unit kilometer Newton meter is 211.36. So, M is 200 kilonewton meter less than M ball is 211.36 kilonewton meter. The cross-sectional of beam is singly reinforced rectangular beam. Step 2. Checking neutral axis depth, x. M equal to 0.454 FCKBX times D minus 0.4x. Times 10 power of 6 is convert from kilonewton meter to Newton millimeter equal to 0.454 times 25 times 250 multiplied by 450 minus 0.4x. Simplify the equation. So, x square minus 1125x plus 176,211.45 equal to 0. With using calculation, key in the information and the answer x is 188 mm and x 937 mm. So, we use x 188 mm cause depth of beam just 450 mm. Checking value of neutral axis depth whether complied the Eurocode 2 equal or less than 0.45 d. X divided by D is 181 divided by 450 and the answer is 0.42 and less than 0.45, so complied the requirement of Eurocode 2. Step 3. Determine the area and the number of reinforcement. We use equation 7b. Refer slide note chapter 3, pages 8. Level arm of the section is D minus 0.4x. So, 450 minus 0.4 times 188 and the value of level arm is 374.88. Area of tension reinforcement is a S equal to moment in unit Newton divided by 0.87 FYKZ. Substitute data in the equation. A S equal to 200 times 10 power of 6 divided by 0.87 times 500 times 374.88 and the answer is 1226 mm square. Then, referring table 1. The suitable size and number of reinforcement is 4H20 with AS provided 1257 mm square, example 1.2. Figure 1.2 shows the cross-section of a singly reinforced beam. Determine the resistance moment for that cross-section with the assistance of a stress block diagram. Given. Characteristic of concrete is 25 Newton per millimeter square and characteristic of steel is 500 Newton per millimeter square. The cross-section of a singly reinforced beam are breadth 250 mm and depth 450 mm and the number and size of reinforcement is 2H25, Solution of example 1.2. A stress block diagram is drawn with the important values and notations as per shown in figure 1.3. Firstly, refer table 1 to determine area of tension reinforcement according the information size and number of reinforcement 2H25 is 982 mm square. Step 1. Checking neutral axis depth, x. Using concept equilibrium with referring equation 4. Compression force of concrete, FCC equal with tension force of steel, FST. 0.454 FCKB x equals 0.87 FYKAS. Rearrange the equation, so x equals 0.87 FYKAS divided by 0.454 FCKB. 0.87 times 500 times 982 divided by 0.454 times 25 times 250 and the answers is 151 millimeters. Checking value of neutral axis depth whether complied the Eurocode 2 equal or less than 0.45 d. X divided by d is 151 divided by 450 and the answer is 0.34 and less than 0.45, so complied the requirement of Eurocode 2. Step 2. Determine resistance moment for that cross-section. We will use equation 5 and equation 6a. If we use equation 5, moment equal compression force of concrete, FCC times Z. 0.454 FCKBX multiplied by D minus 0.4x and substitute information in the equation. 0.454 times 25 times 250 times 151 multiplied by 450 minus 0.4 times 151. And the answer is 167 times 10 power of 6 Newton or 167 kilonewton meter. Or we will use equation 6a for determine resistance moment is moment equal tension force of steel, FST times Z. 0.87 FYKAS multiplied by D minus 0.4x. 0.87 times 500 times 982 multiplied by 1450 minus with 0.4 times 151. And the answer is 167 times 10 power of 6 Newton or 167 kilonewton meter. Okay, thank you for your attention. See you in the next class. Bye and take care.